Hi, my name is Toub. I'm a developer on the .NET team at Microsoft, and I'm absolutely thrilled to be chatting with all of you about getting started incorporating AI into your .NET applications. If you're anything like me, when I'm faced with a new problem about something that I don't really understand, I often have sort of a blank page fear. I'm staring at a blank page. I don't really know how to get started. So what we're going to do for the next 20 to 30 minutes is start from a blank page or almost blank page. We have console write line hello AI, and we're going to see how to start incorporating AI into your .NET applications and go from 0 to 60 in no time at all. Now we're just going to scratch the surface. We're not going to talk about all the various ins and outs. We're not going to dive deep into any one particular area. There are a lot of other opportunities to explore more deeply. What we're going to do today is ensure that by the time you're done watching this, you feel like you can get started immediately incorporating AI into your .NET applications. So with that, let's get started. So here I have Visual Studio. I have a brand new C# console application, and I'm starting with a console application not because that's the only place you can incorporate AI. Quite the opposite. You can incorporate AI into any .NET application. I'm just using a console application to show that there's nothing special here, right? We're just starting from scratch. Now, there are a variety of ways that I can use AI in a .NET application. I need some model or some service that provides that capability to me. And one of the easiest ones to get started using is OpenAI or Azure OpenAI. So I'm going to start with using the OpenAI client. Now to do that, I added a NuGet reference to the OpenAI client. Just search on NuGet for OpenAI. And now I can say using OpenAI, pretty easy. And I can say OpenAI client. So I have my client here. Then OpenAI client. And I need to provide to this an API key, which is the one thing I have to go to the service for. I go to the service and say, hey, I'm going to start using your service. Give me a unique token that you can use to identify me. And so I need to put my API key here. Now, if you look at the constructor for OpenAI client, you can see it takes an API key credential. So we're going to pass in an system client model API key credential. Now, because I don't want to leak my key to any of you, I've put it into an environment variable. I'm just going to zoom out just a little bit. API key credential. We'll bring in that namespace as well. And then I'll say environment, get environment variable. And for me, I've put this environment variable under AI, OpenAI API key. And that provides me with the ability to talk to the service. Now, I specifically want to work in terms of chat. So I'm going to say chat service, and then I'll say client.get chat client. And I need to tell it what model I want to work with. Now, if I'm working with OpenAI, there are a variety of models I can choose from. Here, I'm going to use, say, GPT-4o Mini, which is a relatively recent model that OpenAI has introduced. We can see that this is an OpenAI chat client. And now I can start using it. So I'll say console.writeLine bar results equals chat service dot, and then I'm going to call this complete chat async method to pass in some text and get back a response. So I can say, what is the color of the sky? And then I'll just print that out. Console writeLine result.value. So in 4 lines of code plus a few imports, we're now bringing some AI into our application. It's an interesting completion there. This should pop up once the build completes. There we go. And we can see we're sending off the request. We're getting back a response. And the response was a detailed discussion of the color of the sky. Now, we saw that from the time the window opened to the time that something was printed out, there was a bit of a delay there. So maybe I actually want to take advantage of the fact that the way these models work is they end up generating one token. You can think of that as a word or a part of a word, one token at a time. And rather than waiting for all those tokens to arrive and then printing them all out, I could stream them to, in this case, my console. But if this was a website, I could stream them back to the client. Or if this was a graphical user interface, I could stream it to my graphical UI. So to do that, I'm going to make a small change here. I'll say await for each update in, and I'm just going to do the exact same thing I was doing, but instead of complete chat async, I'll do complete chat streaming async. This is going to give me a stream of updates coming from the service. And then each of those updates can actually include multiple pieces of content. So I'll just say for each item in update dot content update, console dot write item. And that's it. Now when I run this, we can see those tokens starting to stream in as they're coming from the service. No longer am I having to wait for all that content to be here before I see anything. I get it as it arrives, and it creates this nice sort of user interactive experience. And again, very little code to achieve what's actually a few years ago would have been a mind-boggling amount of functionality. Now, here I'm talking directly to OpenAI, and that's great. And there is a wealth of functionality that I can get from this OpenAI client. I can do text to audio, or audio to text, or chat, or generating embeddings, or generating images from text, such as with DALL-E and so on. But for a variety of reasons, you might want to be able to talk to something other than OpenAI, or something other than Azure OpenAI. Maybe you want to talk to Google's Gemini or Vertex. Maybe you want to talk to Mistral AI. Maybe you want to talk to Hugging Face or AWS Bedrock. Or maybe you want to talk to a local model from Windows, or a local model hosted with Olama, or a local model hosted with Onyx Runtime, or a variety of other things. And I'd really like to avoid updating the core logic for the rest of my application, and instead to speak to an abstraction that allows me to talk to any of these services without having to constantly rewrite it every time I change my client. So I'm going to make a few small tweaks here. Let me go back to what I had before, just to keep it simple. We're going to go back to our simple, non-streaming request and response. And instead of using a hard-coded to OpenAI client, I'm going to change this chat service to instead be an iChat completion service. This is an interface that comes from a set of libraries called Semantic Kernel. You can see we brought in a namespace from Semantic Kernel here. Semantic Kernel is a variety of things. It's a whole stack of functionality. But at the bottom of the stack, there's a layer of simple abstractions for talking to language models and other AI services. So instead of using the OpenAI client directly, I'm going to create an OpenAI chat completion service. As we saw before, I can pass in a model. So I'll pass in, say, a GPT-4o mini. And then I'm going to pass in the same API key as I did here. These also layer. So if I wanted to pass that OpenAI client to this OpenAI chat completion service, I could. And now I just need to make a little change here to change to a different method name, because I'm using the abstraction rather than that OpenAI client specifically. So we've cleaned up the code a little bit. We're dealing with this interface directly. And now I can replace this interface with anything I want. So I can run this for OpenAI. And when this runs, eventually my build will complete. So here we're going to get back the answer from OpenAI. But if I wanted to, let me just replace this. I'm not going to change any of this logic in the rest of my application. I'm just going to change my startup logic here to say, actually, you know what? I want a Google Gemini chat completion service. Now, Google provides entirely different models. So the name here I want to use is Gemini Pro. And then I'll also provide an environment variable here. I've actually called mine AI Gemini API key. And without changing any of the remaining logic in my app, I'm going to run it again. And now instead of talking to OpenAI, now I'm talking to Gemini, and you can see these models are a little bit different. OpenAI gave me a very wordy response by default, and Gemini is just saying the color of the sky is blue. If I wanted to, I could substitute something else. Maybe I want to talk to Mistral AI. So I can have a Mistral AI chat completion service. Mistral calls one of their models Mistral Small, so I'll use that, get environment variable, and I'll do the exact same thing. I believe my environment variable is called Mistral AI. Run this again. Oh, nope, not Mistral AI, just Mistral. And now we get back, eventually, a response, a much more detailed response from Mistral AI's model. So you can see I'm getting different behaviors from the different models and services that I'm talking to, but the logic of my application is able to remain the same because I'm working in terms of these abstractions. And if you want to, you can start with these abstractions, and if you need to do something specific to the underlying client, you can break glass and basically cast back to the original thing to have the full functionality. Great. So we've got a very basic functionality here, but I was just using a hard-coded question. So let me just go back to OpenAI here. And I'm going to write a little simple chat loop. Now, even though this is called chat, that's not the only purpose. This is sort of a general purpose way of interacting with the service. One of the purposes is to have a conversation with it from, for example, a chatbot. But you can also use this for more programmatic purposes. I could ask it to compute something, send me back the results in some structured form like JSON. I can then parse it, and I can use the result as a computation in the rest of my application. So incorporating AI into your app doesn't just mean build a chatbot. It can actually mean take advantage of the power of AI to power your application, which might not have any kind of chat feature in sight. That said, I am going to build a little chatbot here. So say while true, we're going to have an infinite loop. And instead of printing out the answer to a specific question, I'm just going to type in a question at the console, and I'll print out a little prompt to say Q. Right? And now I can run this. And I get my little Q, and I can say, hello. It's nice to meet you. My name is Stephen. Nice to meet you, Stephen. Great. What's my name? I just told you, so you should know, but you don't. And the reason for that is these services are stateless. Every time I communicate one of these, I'm talking to a model that was trained up to a certain date. It has no information beyond that. It has no information that I previously told it. All it knows is what I just sent it as part of the prompt that I'm sending to it. So if I don't tell it again, when I say, what's my name? If I don't tell it all the previous communication we had, it has no idea who I am. So let's fix that. To fix that, we need to store our conversation history and resend that conversation back to the service each time we communicated with it. So I'll say chat history, call this history. And then instead of just passing this console read line directly to the model, I'm going to say question, or I'll say history.add user assistant message. I'll add that read line in there. Then instead of passing console read line here, I'll pass in the whole chat history. And when I get a response back from my AI assistant, I'll not only print out that response, but I'll also add it into the history. So now every time there's additional content, I'm putting it back into the history. And every time I communicate with the service, I'm sending the whole thing back. Now we can have the exact same interaction we just had. I can say, hello, my name is Stephen. I can say, what's my name? And now it knows who I am because we've reprovided all of that context back to it. Of course, if I were to say, how old am I? It has no idea, right? It doesn't know who Stephen it is. It doesn't know who I am. I have not provided it with the information it needs to answer that question. Now, I could proactively put some additional information into the prompt. I could say, add user message. Stephen is, I don't know, 29 years old. We're going to make up a number here. And now I can have the exact same conversation I just had. Hello, my name is Stephen. And I can say, how old am I? And now because I just told it that I'm 29, which I'm not, but I told it I'm 29, it says, hey, you told me you were 29, and it can use that information. But I don't want to have to put all possible information into the prompt. I want to be able to allow the model, allow the service to ask me to retrieve additional information. So to do that, we're going to make a few changes here. Now, first, you notice I've got my application logic, and I've got my sort of startup logic here. Now, in a real application, you would unless you were writing a simple tool, a simple console app, you're probably not going to commingle these. You're going to have some startup logic somewhere that most likely is injecting the implementations of various abstractions that you're using into a dependency injection container, maybe as part of your ASP.NET startup. And then in the rest of your application, you're going to be taking that dependency injection container, you're going to be querying it for the various interfaces. And that's one of the most common ways that these APIs end up getting used. So let's do that here, and then we'll come back to the age thing in just a moment. Now, if I were already in an ASP.NET application, or if I were already in a MAUI application, I would already have a DI container kind of established for me by the template I was working in or by the environment. Because I don't have that in just a console application, I'm just going to set up a little one myself. So I'll say service collection, and I'm going to get out of this the same service provider that you would get and you would have handed to you in other environments. And now I can add things into my service collection. One of the things I could add would be an OpenAI chat completion. This is going to take the same arguments that I had down here. So I'm just going to copy and paste that. Get rid of this. And now in my application, when I want to use a chat service, I can just say services.getRequiredService, iChat completion service, and use this. And so now in my startup logic, I can change to use whatever service I want to use, whether it's a local model or a remote service, whatever it might be. Maybe I want to change it for testing purposes to mock something up. Maybe I want to be able to have some fallover behavior where if the service I'm talking to has an outage, I can switch to something else. Maybe I want to do A/B testing. Maybe I want to insert an additional wrapper, some additional functionality around this, like a cache, so that rather than going off to the service every time, it looks up in a cache before it sends the question and gives me back the results. I can do all that by changing my configuration logic up front and then just having injected into my application the thing that I should be working with. So that's what I'm doing here. And we see it behaves exactly the same. I can say hello and we get back responses. Now, what we talked about wanting to do was to add additional functionality into this application. I'm going to do that using something called a kernel, which is one of the core types that comes with semantic kernel. And all it is a little object that stores services and in particular plugins, additional functionality that can be made available to the model. So I'm just going to say add kernel just to make sure that I can get one of these from my DI container. And out here, I want to get a kernel from DI. Great. And now I want to be able to add some functionality into this kernel that will allow the model to know, without my telling in advance, how old I am. So I'm going to come down here and write a little class. Let's call this demographics. And I'm going to write a function. Let's call this getPersonAge. That takes a name. And we'll say name switch. If it's Stephen, we'll say, let me say 29. Yeah. If it's Elsa, we can say 21. If it's Anna, we can say 19. And if it's anyone else, we'll say 40. Seems reasonable. I'm also going to mark this as a function that I want to be able to import into this kernel. And now all I have to do up here is say kernel import plugin from type. And now using reflection, this is basically just, excuse me, inspected an instance of this type to find all the kernel function objects. It's imported this function. And I can add additional metadata here. I can add descriptions of the properties, the parameters, and the function. I'm just going to leave it as is for now. Now I'm going to do two more things. First, I'm going to create a settings object that I can pass along with my prompt to configure various things. You can see Copilot is suggesting here various settings that I might want to configure. But what I actually want to configure is I want to tell it that it's allowed to automatically invoke the functionality that I'm providing. Then I'm going to come down here is I'm going to say settings and kernel. So I'm passing in these options, including the ability to automatically invoke this stuff, and I'm passing in this kernel object that just contains these plugins. Now when I run this again, and I say, hello, my name is Stephen. Oh, or let me try that again. My name is Stephen. How old am I? Now, because it had this ability to call back to me, it knows that I'm 29 years old. Or I can say, how much older is Elsa than Anna? And again, it doesn't know how old Elsa is. It doesn't know how old Anna is, but it was able to ask me to invoke a function with Elsa, and it knows that that's 21. Then it knows that it's 21. It was able to invoke it with Anna, and then it knows that she's 19. And then it was able to do the logic to know that there's a 2-year difference between them. Now, because we're taking advantage of this integration with DI, and it's fully integrated with the rest of the .NET ecosystem, we can bring in other functionality here to get a much better understanding of what's actually happening under the covers. So let me add in some logging, for example. I'll say add logging. And I'm going to do console logging, and we're going to have it be the most verbose level. So we'll say log level trace to add this logging. Now we'll run this again. Now we can see, we already see some information being output just by adding that into the DI container. Now I can see that we imported this get person age into the kernel. We have one function available. And if I say hello, we can see the message, the chat message that's being sent up. And as part of this request response, we can see that I used 42 request tokens, prompt tokens, as part of my request. And the answer that came back had 10 tokens, meaning that the total number of tokens used was 52. And that's important for two reasons. One, with pretty much all of these systems, you are limited by how many tokens you can use. Every model has a different context window or token count that's allowed for both the request and the response. So I might want to keep track of it for that purpose. Also, most of these services bill you based in terms of the number of tokens used. So it's important to understand from a cost perspective as well. Now, if I ask it a question like, how much older is Elsa than Anna? We see we sent another request, and this time we get a lot more interesting, many more interesting things happen. We got our initial request response, but as part of that response, the response it sent back to me had two tool requests. One of them was to invoke get person age with the name Elsa, excuse me, and one of them was to invoke get person age with the name Anna. And then because we told semantic kernel it was okay to invoke these things, it proceeded to invoke get person age with Elsa. It succeeded and returned the result 21, taking this amount of time. Then it invoked again get person age, passing in Anna. It succeeded, returned the result 19. It took this amount of time. That we turned the crank again. We made another request back to the service, sending all of those results back, along with all the previous chat history, which contained our original question. And then we get back the result from the service saying Elsa is 2 years older than Anna, because now it has all that context. Now, in this particular case, I wrote my own plugin, which can be arbitrary .NET code, but you can imagine reusable libraries of this kind of functionality. In fact, semantic kernel, as one of its libraries, includes a set of plugins, one of which is really useful for these kinds of examples because it allows me to do full web searches. So I could come in here and I could say, I want to import a plugin from a new object. And this new object is going to be a Microsoft semantic kernel plugins web, what do we call it? Web search engine plugin. And then this takes a particular search engine to talk to. So I'm going to use the Bing connector. And I also need to give this an API key, which is also for me stored in an environment variable. So we pass in API key. And now let's try this again. So I've added in that plugin. We can see it imported an additional search API. And now I'm going to say who won Best Actress at the 2024 Academy Awards. Now, the model that I'm using has a training date before the 2024 Academy Awards appeared, so it wouldn't be able to answer this question otherwise, but because it can now search the web, oh, I can't search the web. Apparently, it's getting permission denied. It's possible my API key is out of date. We'll try one more time, and we'll see if it works. Otherwise, we'll move on. Who won Best Actress at the 2024 Academy Awards? No joy. Doesn't matter. We can still see what we wanted to see, which is that as part of my request, the tool came back saying, I would like you to issue a search for 2024 Academy Awards Best Actress winner. So the model was generating this request, handing it off to the plugin, and for some reason, my API key isn't working out exactly the way I want, and Bing is saying, go away. That's fine. You get the basic idea. All right. All right, we have a couple minutes left. So you can see that you can build up these really powerful AI experiences with very little code. We've only scratched the surface. I'll show one more aspect of this. Let's say that as part of these plugins, I wanted a little bit more control over throughout my application, maybe what got invoked. I put a bunch of stuff in, but then if the model asks for something, or maybe it asks to invoke something with some arguments I don't want it to do, I want more control over exactly how that happens. So I'm going to write a little class here. Let's call this permission filter. And I'm going to implement a function invocation filter. Function invocation filter will be invoked anytime a function is to be invoked. So let me just print out to the console here what function is being invoked and ask for permission. Okay to invoke context.function name and context.function.name. And I want to do string.join with the arguments just to put a nice little list. And then I'll say if console.readline, so I'm going to just ask the user to type in yes or no, then yeah, we'll do that. Otherwise, we'll throw an exception. Let's just say error user denied request. Okay. So I've written this filter, and now anytime the system asks for one of these things to be invoked, I want this to be invoked. With dependency injection, it's no problem. I just say add singleton. I want to add a function filter in. We'll use a permission filter, and now I'll run this again. Actually, let me just turn off logging to make it a little bit easier to see what's going on, so we're not surrounded by noise. And I'll say who won the 2024 Academy Award for Best Actress. And now, rather than just invoking it, you can see it's actually asking me, this is the function that's going to be invoked, the function that's going to be invoked with these arguments. Is this okay? And I could say, yeah, sure, go ahead. Or I could say no, and it basically gets denied. And it's trying one more time, and the model gives up. It says, you know what, I wasn't able to do what I wanted to do. I'm done. And so you can very easily plug in this functionality in one place and have it kind of apply pervasively throughout the rest of your application. So with very few lines of code, we've seen how to get started using something like the OpenAI or Azure OpenAI client directly. We've seen how to switch over to using interfaces and abstractions from semantic kernel to be able to talk to OpenAI or any number of other services. We've seen how to employ function calling with models and use various plugins. We've seen how to use various filters. We've seen how to do streaming. And that was starting from a blank page in only 20 to 30 minutes. Imagine what you could do with a day or more. So my hope is that all of you watching turn off YouTube, go open Visual Studio, and add these NuGet packages and just start playing and see what the amazing things are that you can build. And with that, thank you.